In this video, we're going to talk about solving quadratic equations using completing the square. Solving quadratic equations this way basically changes a quadratic equation that is in general form, which looks like this: ax squared plus bx plus c equals 0, into a form that would be more usable for solving by the square root property. That's actually how you end completing the square problems, is by using the square root property to finish the problem. So what we're going to do is go through the steps that you have to go through to work one of these by completing the square. We will do that with an example as we talk about what each step is, and then we'll go through a second example without writing the steps down. So let me give you the first step. Alright, so here's an example. Solve by completing the square. X squared plus 8x minus 7 is equal to 0. Your first step is to divide both sides by the leading coefficient. That's your coefficient on the x squared term right here, okay? That would be your a value. For this particular equation, I do have an a, and the a is equal to 1, but if we divide each term here by 1, it's not going to change anything. So unless this is a number that is something besides a positive 1, you don't have to divide through by that value, so we'll kind of skip that step. After you've divided through by that leading coefficient, or in a case like this, if your leading coefficient is 1 and you don't have to divide through, the next thing you're going to do is to move the constant term to the other side. Our constant here is this negative 7, so what I will do is add it to both sides. Scoot up just a little bit. And so that's going to give me x squared plus 8x is equal to 7. Now what we're going to do is take half the coefficient on x and square it. Your coefficient on x here is 8, okay? So off to the side, what you can do, just a little bit, is take half of 8 and then square it. So half of 8 is 4, and 4 squared is 16. So 16 will be the constant that I'll add back to both sides. So 16 is what we'll add to both sides, and I've got x squared plus 8x plus 16 is equal to, that's 7 plus 16. So I've got x squared plus 8x plus 16. Let's go ahead and combine these two. That's going to give me 23. Okay? The step you just got through with is actually the completing of the square, okay? The square that's referred to here is this perfect square trinomial that you completed when you added the 16 in. So our next step is to take this trinomial and factor it. Since it's a perfect square trinomial, there is a special factoring formula for that you can use if you want to. Or if you'd rather factor it as just a regular trinomial, that's possible as well. Regardless, what you need to do once that's factored is write it as a binomial squared, okay? That will always happen because the way you created this, you completed the perfect square trinomial, which will always factor into the square of a binomial, okay? Then we'll have the equal 23 over here. So let's talk about what goes in this set of parentheses. How is this binomial created? All right, if you use the formula for factoring perfect square trinomial, it is the square root of the first term, which would be this, okay? The square root of x squared is x. Then you take the first sign, which is this plus right here. I should say the sign on the second term really is better because this is a positive out here as well. We just don't see it. So it's the sign on the second term, and then it's the square root of the last term. That's the last thing that we'll put in. So the square root of 16 is 4. X squared plus 8x plus 16 factors into x plus 4 squared. That's where that comes from. Like I said, that's your completed square. That's the square it's talking about you completing. And from here, what we do is we finish up by using the square root property. And this process is called the square root procedure in some books, including the textbook that we're using. It's also called the square root property in other places. And what we do to solve using a square root procedure, you have to have an expression that's squared on one side of the equal sign, like we do here, and then a constant on the other side. You can use the square root procedure in other situations, but the ones we're looking at right now fit this profile perfectly, okay? No extra terms. You only have two things, a binomial squared on one side and a constant on the other. So what we do is we take the square root of both sides, and when that happens, you put a plus or minus on the side with the constant. Square root on the binomial squared side just succeeds in getting rid of that square. And then on the other side, we do have a square root above the 23. 23 is not a perfect square. Doesn't have any factors besides one that are perfect squares. And so there's no simplifying the square root of 23. All we can do at this point is solve for x, and we do that by subtracting the 4 from both sides. Now, if you're working this problem for WebAssign, since this has a plus or minus in it, WebAssign will want it split up into two different things. WebAssign does not have a plus or minus symbol, and so you do have to write two separate expressions. This weird looking thing right here is a comma. Sorry about that. It just looks bad on the screen there. But it's -4 plus square root of 23, and then -4 minus the square root of 23 for your second part. Okay? Now, let's take a look at one without having to write down all those different steps throughout. One that's a little bit more complicated that will involve us having to get a few fractions within the problem. So okay, so this is the one we're going to work on. 2x squared plus 6x minus 7 equals 0. The first step is to divide through by that leading coefficient, the 2. Now the reason why we have to do this is when we complete our square, we need the trinomial that we are creating to have a leading coefficient of +1. So we get that coefficient out of the way in this step. So divide everything, every term, by the 2, okay? And of course right here, this is just going to be a 0 again. 0 divided by any number is still just 0. So 2x squared over 2 gives you x squared, and then 6x over 2 is going to be 3x, and -7/2, we keep like that, equal to 0. Your next step is to move your constant to the other side. So we need to add 7/2 to both sides. Notice that we do have a fraction involved at this point. It's not terribly hard to work with a fraction. You just have to be able to add and subtract. Fractions get common denominators, that kind of thing, to be able to work them with those in there. Okay. The next step is to find that constant that we're going to add back to both sides, and we do that by taking half the coefficient on x and squaring it. So if I square 3/2, I'm going to get 9/4. Okay, it doesn't reduce. That's got to be added back to both sides. We'll need to get a common denominator there, okay? So think about what this needs to be changed to. If I want a common denominator of 4, I've already got a 2, so what do I need to multiply to make that a 4? We would need to multiply top and bottom by 2, okay? So let's go ahead and do that. 7/2 would become 14 over 4. Okay, and now we'll go ahead and put those two together. Whoops. Go back to the pencil here. x squared plus 3x plus 9 over 4 is equal to, if we add those up, 9 and 14 give me 23 over 4. Okay, now take your trinomial right here and go ahead and factor it. You factor it the same way we factored that other one. This one would be a little tricky if you were trying to factor by just regular trial and error because of that fraction. But if we use the factoring formula, it's a lot easier. Square root of this. All right, so what we're going to get is the square root of the x squared. First sign right here, or rather the sign on the second term, that's what I should say. And then the square root of our last term, square root of 9 over 4. When you take the square root of a fraction, you just take the square root of the top and then the square root of the bottom, okay, separately. So, square root of 9 is 3, and the square root of 4 is 2. And that's what we've got. Now we finish up by doing the square root property. I've got the square of an expression on one side and the square, and a constant on the other. We don't have to have a perfect square constant. So I take the square root of both sides. We get x plus 3 halves is equal to plus or minus the square root of 23 over 4. We can take the square root of the 4. We can't the 23. That's actually good news because in algebra, a rational is not considered to be simplified if there is a radical in the denominator, okay? So we'll go ahead and we will simplify that. And all we have to do there is split up the root so that we still have the square root of 23 on top, and the square root of 4 is 2 on the bottom, okay? And then just subtract the 3 halves from both sides, no big deal there. We're not actually combining, so even if we were, we have a common denominator, so it wouldn't be a big deal. Negative 3 halves plus or minus the square root of 23 over 2. Okay, and again, that does give you two answers. Okay, you've got the negative 3 halves plus square root of 23 over 2, and you have the positive 3 halves minus. I'm sorry, the negative 3 halves minus, I switched the wrong sign. Square root of 23 over 2. Like that, and that's your answer.